welcome to Class Connect study series with Yusuf Arikewuyo. Today we shall be looking at the concept of measurement and measuring instruments. Measurement deals with the act of ascribing numerical equivalence to the worth of a quantity with respect to a laid-down rule which is acceptable. To measure, measuring instruments are utilized. Measuring instruments can be traditional or modern. Traditional measuring instruments refer to those techniques, methods, or ways used in the ancient times for measuring quantities. For example, in the ancient times, people make use of cockcrow or shadow for measuring time. People make use of handspan or the foot length for measuring distance, amongst other methods. Traditional measuring instruments suffer from universal acceptability and reliability. Oftentimes, the measured value may not be valid in certain instances. For example, the foot span or the foot length measured in a particular area might not be the same when it is measured in different area. Since the person who measured in city A is not going to be the same person who will be measuring in city B, definitely there will be a variation in their measured values. Modern measuring instruments refer to the newly developed methods, techniques, or tools used for measurement. These are tools that are developed to face the challenges of the modern era. Modern measuring instruments are universally acceptable as they follow internationally acceptable standards of measurement, such as the SI unit system. What this means is that when a particular measurement is taken in a city and such a measurement is retaken in another city, there will be a very high chance of getting the same value since a standardized measuring instrument was used. For every measured quantity using a standardized measuring instrument or a modern measuring instrument, there is usually associated an SI unit. What this means is that when, for example, we measure length, we denote it by using meter. When we measure mass, we denote by using kilogram. When we see, for example, a measurement, say 15 meters, it is quite different from when we see 15 kilogram. In the first instance of 15 meters, we are dealing with length, while that of 15 kilogram, we are dealing with mass. Let's now examine the measurement of some quantities. We shall start by considering the measurement of length. To measure the length of a quantity, we can make use of a tape rule, a meter rule, vernier caliper, a micrometer screw gauge, amongst others. All these are modern measuring instruments. Next, we shall consider the measurement of mass. The measurement of the mass of a substance can be done with the use of a balance, such as the beam balance, the chemical balance, the triple beam balance, the lever balance, etc. Measurement of time. To measure time, a wristwatch or a wall clock can be used. In the laboratory, stopwatches and stop clocks are used. This could be digital or analog. It should be added that the atomic clock gives the most accurate measure of time. The vernier caliper is shown below. From the diagram, we notice that the vernier caliper has two jaws, one called the internal jaw, while the other is called the external jaw. With the internal jaw, we can measure the internal diameter of some shapes or for some circular objects, while with the external jaws, we can measure the external diameter of some objects. And of course, we have so many parts such as the locking screw, which is used in tightening or making the grip on the measured object so hard. And of course, we have the imperial scale, the metric scale, and the extension bar, which is depicted as the depth measuring blade, which can be used to measure the internal length of a substance. To measure using the vernier caliper, two scale readings are taken, that is the main scale reading and the vernier scale reading. The addition of these two scales gives the reading of the measured value. What is the reading registered on the vernier caliper shown below? This is a practical representation of a vernier caliper. And of course, we have two scales just like we showed earlier, which of course the point here, the main scale represented with letter M, and this point here is the vernier scale. To measure the main scale, we look for the reading just before the commencement of the vernier scale, which of course the reading here is 5 5.90, and of course centimeter. Then the vernier scale is just the portion below the main scale, and we look for the point of perfect coincidence with the lines on the main scale, and the point that coincides perfectly is this 0.06 mark, and of course centimeter. And if we add the two, the reading registered on the vernier caliper is given as 5.96 centimeters. Let's consider this question. We are told to state the reading of the vernier caliper shown below. Like we did earlier, the top portion corresponds to the main scale. Let's denote that as letter M, while the bottom corresponds to the vernier scale. And on the main scale, the reading registered just before the commencement of the vernier scale is 0.50 centimeter. And on the vernier scale, the reading registered at the point of coincidence is 0.02 centimeter. And if we add up the two, we shall have 0.52 centimeter. That means the vernier caliper registered a reading of 0.52 centimeter. It should be added that the measuring accuracy of a vernier caliper is 0.01 centimeter, which is equivalent to 0.1 millimeters. Let's now consider some work examples involving the micrometer screw gauge. Just like the vernier caliper, it also has two scales. First, the main scale, and the reading here, which gives the vernier scale. What is the reading on the micrometer screw gauge shown below? Just like the vernier caliper, there are two scales on the micrometer screw gauge. The first, the main scale, and lastly here, it gives the vernier scale. Coming from the main scale, if we start from 0, we have 0.5, we have 1, 1.5, 2, 2.5, and 3. And before that, there is no other reading after that, So the main scale reading here will be 3.00, but this time around millimeters. And the vernier scale, we shall look at the point of perfect coincidence with this thimble line, and the point of perfect coincidence with the thimble line is this particular point here. So that the reading there, if this is 10, this will be 11, this is 12, this will be 13. So the vernier scale reading there will be 0.13 millimeters. So the reading registered on the micrometer screw gauge is nothing but 3.13 millimeters. The reading accuracy of a micrometer screw gauge is 0.01 millimeters or 0.001 centimeters. Similarly, let's consider this question. We are told to get the reading registered on the micrometer screw gauge shown below. So we get our main scale reading, let's note this as M, and of course our vernier scale reading, let's note this as V. From the main scale, we have this point as 8, this point 8.5, this point 9, 9.5, this point 10, and this point 10.5. So we record 10.50 millimeters. And on the vernier scale, point of perfect coincidence with the thimble line, which of course is this point, is given as 0.35 millimeters. And if we add the two, we shall get 10.85 millimeters. And therefore, the reading registered on the micrometer screw gauge is 10.85 millimeters. Thanks so much for watching. Hope to see you in our next class, and please do not forget to subscribe and click on the notification button. Thank you.